pi/30.
Pi/30. Does everyone agree? Why?
2 pi/60.
Okay, we got 2 radians. Does everyone agree? In 60 seconds.
Yep.
I just sit down and talk.
Oh, so it's really all Alyssa?
That is angular speed, so that's half of it. So that's what angular speed is.
You figured that one out.
So pi/30 radians per second. Any questions on that? Good. So that is angular speed. What does that mean? Well, we've got how many radians do we move in a certain amount of seconds, and that's what angular speed is. So we're going to learn 2 things today. Linear speed. Linear speed is what we think about with speed. Miles per hour, feet per second, it's speed. However, if we're looking on a circular path, we will have to work a little bit harder to get the distance because it'll be a piece of our circumference. But an arc length. Linear speed is how fast the particle is moving in distance over time units. So instead of angles over time, linear speed is distance over time. The notation for that is v. Why do you think they use v, you physics people? Velocity. And they use s for distance and t for time. They use the s on arc length problems. They don't always use the s for other distance problems. Sometimes they do. V is the linear speed. S is the length of the arc. Because if we're going to get distance over time, we would need the length of the arc. We know how to find arc length. Yeah, it depends on if we're in radians or if we're in degrees. If we're in radians, how do we find arc length in radians? Good. Radius times the radius, and how do we find arc length if we're in degrees?
Degrees divided by 362 pi.
Perfect. Now remember those formulas. There's about angular speed. Angular speed is measured in radians over time. Depending on the time, it could be seconds, minutes, hours. But angular speed is measured in radians over time. They denote this with what looks like a W. It's actually another Greek letter. It's omega. You ever know that? So omega is the angular speed. Theta is the measure of the angle in radians, unless otherwise stated. We will always do angular speed in radians of a point moving around a circle. So you already did the second hand of clock. You found the angular speed of the second hand of clock. Radians over time. Any questions on that? These are some formulas you need to know. Sort of. If you haven't noticed, a few things I've talked to you about right now, by now, if memorization is great, but if I could just recreate it, maybe I don't have to lose my brain space in there. So you can memorize them, or you can understand them. I kind of prefer understanding, but if you get stuck, you can go back and memorize. Angular speed is always radians over time. Done. Nothing with that to remember. But linear speed can be calculated a couple of different ways. We know it's the distance over time. That doesn't change. It is distance over time, always distance. But we did learn from you, r theta, you said that? Paxton said that distance on a circle is r times the angle, r times theta in radians. So, if we know that, we can do r theta over time. The one weird one is the last one. What is theta over time? Omega. So the last one is the only one you might need to memorize because it's not necessarily intuitive, right? You don't go, oh, well, distance over time like you do on the other. But r, which is the distance, times the angular speed also will give you the linear speed. So that last one is one worth writing down. And you probably didn't just know that. It makes sense once you look at the formula, but it's one you might not have known. Any questions so far? R is the radius. So if you take the radius and multiply it by the angular speed, you get linear speed.
It's the W circular thing.
It is omega. It's the angular speed.
Draw that.
Where we can use this, and we will use it more tomorrow than today. Today we're just walking through the formulas, figuring out how to work things. Tomorrow we'll do some application problems. But if you know how fast your tires are rotating, should you be able to tell how fast you're going? That's what your speedometer does. Does it change things if you change the size of your tires? Have any of you ever done that? You get bigger tires and you don't adjust, you will get a ticket because you will be going too fast. Because your angular speed hasn't changed on your speedometer, because your speedometer is calculated based on how many rotations per hour, right, your tires are going at. And so they calculate your speed based on that. Well, if you change the size of your tires, it changes your linear speed. And you might not know that you're going at different speeds than your speedometer says. But the angular speed is the same. We'll talk about that. So it has applications. For today, we're just going to kind of work through some problems, see if we can figure out linear angular speed problems. So, suppose that P is on a circle with radius r, and ray OP is rotating with an angular speed of omega. For the given values of r, omega, and t, find the following. I'm going to find the angle generated by P and t, the distance traveled, and then the linear speed. So this one doesn't ask angular speed, but it gives you angular speed. And that angular speed is in seconds, is in radians per second. I probably should have put that up there. So, what is the angle generated after 6 seconds? Well,
Over 12 for me.
okay, pi over 12 is how fast I'm going, right? What's the units on that? Radians per second. If I do that for 6 seconds, I do 6 of those, right? 1 pi over 12 in 1 second, 2 pi over 12, 2 seconds, all the way up to 6 seconds. Everyone agree?
Pi over 2.
So, pi over 2. Now, did we use a formula to do that? Could we use a formula? We could. I'll show you a formula. But I like the way you did it better. Right? I like that better. I want you to do that. But if you got stuck,
No one got stuck.
which formula uses omega and the angle and the time?
R theta.
Yeah, but that has another variable. I want one with only W, theta, and T.
R omega.
Angular speed.
Angular speed.
That, right?
Yes.
And so omega is pi over 12. T is 6. Could I find theta using the formula?
Yep.
Yeah. Okay. So, I agree with you. You cross multiply by 6 so you can land in the same place. Okay. So that's the formula way, and you already said how to do it by thinking it through. On the formula? Okay, so this formula was on the last slide. I know W, I know T, and I solve for theta. Give her credit.
I was trying to help her out.
Okay, any questions about that one? Now, the other thought process, the think it through process is that I'm moving at 5 or 12 radians per second for 6 seconds. So you multiply by 6, which gives you the same. Both are great. I don't care what you do. Speed, the distance traveled by p in time t. How do we get linear distance? What's a word for distance on a circle?
Arc.
Arc length, right? So this is really asking what's the arc length,
So
right?
P equals R angular over T.
Okay. So I want to know the arc length. I want to know the distance, right? Distance traveled. So I got a couple of options, don't I? Okay, what are my options? R times theta? That's the easiest option, isn't it? I learned that 3 days ago, right? R times theta is the arc length formula. Do I know R?
Yes.
Do I know theta?
Yes.
So can I find R times theta?
Yes.
So, part B, I know that the distance is R times theta.
Yeah.
R is 20 centimeters. Theta, what is theta? Pi over 2. So you kind of see why they asked that question first. It made that question a lot easier.
Yep.
So I get 10 pi what? What is this again?
Centimeters.
The distance, right? So it's in centimeters. So far? And then how do you do linear speed? Distance over time, right? I have distance, don't I? What are my units on that?
Radians per second.
It's centimeters per second.
Why centimeters? No.
We got 10.
10 pi was a centimeter,
6.
and a 6 is a
That's
second.
all it is.
So watch those units. I get it. How far? This is how we worked A. The answer was pi over 2.
Wait, A was
Which one? First one? This one. We know this distance is R times theta. R is 20. Theta in part A was pi over 2. So 20 times pi over 2. And yes, 10 pi over 6 is the same as any questions? So that's kind of some using a formula or using your brain. Either way, they work great.
Yeah.
So this is kind of like the bell ringer. It just asks the question a little differently. Instead of asking for angular speed, or the speed, what did it say? Find the speed of the second hand in radians per second. This one says find omega for the hour hand clock. Because it doesn't tell us what units to use, there are multiple correct answers. We know it has to be radians, but we could do radians per hour. We could do radians per second. We could do radians per
day.
you could. Minute or day or whatever, right? So there are question is if you did minutes, right?
Yes.
But could we change it if we wanted to? You could convert it, or you could think about how many minutes it takes the clock to be 60 times 12, right? How many minutes it takes the clock to go there. But this is, so it would be pi over 6 radians per hour. That is the easiest answer.
2 pi would be, oh, it's over.
Now, quick question. Does the clock move a 6 like, does it move pi over 6 every hour? Yeah, because one pi would be at the 6, right? And so a 6 moves a 6 pi every hour. Makes sense. Got another one. What time do we get out of here? 10 after? Right, or half days? 5 after? Okay, let me really quick show you the homework. This is a 2-day lesson again. Page 239, 34 through 42 even. Those are the problems like we've been working today. You can probably do them all today. It's next Wednesday, so it's Friday. I do have 5 challenge problems for you. Though you are welcome to look at them tonight, I would love for you to. If you feel like you can't do them all tonight, tomorrow's notes will help you do the challenge. So don't feel like I will teach you how to do it. But it would be great if you want to look at those, see if you can do it. But if not, the good problems, definitely do those tonight.
It's gonna be like it's on your going. Let's go back to your show recording. Right.
How do you listen to it?
Go on Edline, and there's a thing on Edline that says video lessons. Click it, and it'll bring up a YouTube video. It's not just the listening. Like you see me writing and everything.
Last time.
But I'm going to Friday. I'll take them up together on Friday.
Are you gonna do that all throughout the year, 2 days?
In trig, I do a lot of 2-day lessons. In calculus, it seems like I don't do as many. Only occasional ones. More in trig than in calculus. There is more homework in trig than there is in calculus. A little bit. Okay. Find the angle generated by T in 10 seconds. Okay, so we're going pi over 12 radians per second for 10 seconds. What are we going to do?
Say pi over 12.
Okay, multiply. Now, those of you who didn't see that, we are using this formula, right? If omega equals theta over time, then wouldn't that mean that omega times t equals theta? Multiplying the t over. So just rearranging that formula. So if you want to add that formula to your list, you can. It's just a rearrangement of that first formula. But omega times time will give you your angle. So I'm going pi over 12 radians per second times 10 seconds. Do you see why that gives me the angle? Units wise, units cancel, the second cancel. And it gives you 10 pi over 12 or and that is my angle. 5 pi over 6 is my angle. That is a 30-degree reference angle and 5 over 2. Find the distance pi along the circle in 10 seconds. How are you going to find distance?
Speed over time.
Just distance, not speed, just
D times speed.
right? This is really a better way to ask distance if you're on a circle is arc length. Anytime you see distance, we're going around a circle, you read arc length. Is that formula on today's notes?
No.
No, where would you find that formula?
2 days next year.
No, Friday's notes. So r times theta is the arc length, which is distance. Do I know r?
Yes.
Do I know theta? That is measured in 15 times 5.
Distance is what's the unit?
Where did you get that inches unit from? 15. Find the linear speed. What would the linear speed be?
Distance times radius.
Distance over time. Now, in this case, they made us find the distance to begin with, but if they didn't do that, would it be okay? We could do that in one formula if we needed to.
So S means distance.
Wish I would have said it.
I know. You should listen to the recordings.
I can get it though.
Oops.
Any questions so far? We have.
Yes.
What are the units? And why is it 10? Good question. Why is it 10? If that's the angle we were using, that it had been. So this would be 75 pi over 60, right? How do you divide two fractions?
Multiply the bottom.
So we multiply 75 pi over 6 times 1 10. Sorry, I lost my 5 there somewhere. 5 pi. And inches per second. 75 pi over 60, that those two. Any questions so far? Oh, that's pretty smart.
3 over 2.
Oh, we could have done omega times radius.
I actually said that.
Sorry.
That's okay.
Hey,